All right, class, so we're now on section 3.4, properties of logs. And so logs are like my favorite type of function, mostly because of these nice properties. So in this section, you'll be able to apply the product rule, quotient, and power properties of logs. You'll also be able to write a log in expanded form and then write a log as one single logarithmic form, so condensing it, and then apply the change of base formula. So let's talk about the very first property, product property of logs. Okay, so suppose that b, x, and y are positive real numbers where b is not equal 1. All right, so b is going to be the base of our log, so we can't have a base be 1. All right, so the product rule says that if we are multiplying inside of our log, so log base b of x times y, then we can break it up into two separate logs where instead of multiplying, we actually will add. All right, so we can break up multiplication inside of the log into separate logs with the same base, but add those together. All right, so let's do number 1. So it says write the logarithm as a sum and then simplify if possible. And so again, x and y are positive real numbers. Okay, so note, we have multiplication right here. So log base 2 of 8 times x, so that tells us, oh, we can break this up into two separate logs. And so we want to add. All right, so this is perfectly fine as a final answer, but the instructions say we need to simplify if possible. So let's look right here, log base 2 of 8. Could we simplify that? I actually think we can. So remember, this is the base, and we've talked about these other properties where we can cancel out bases. All right, so could we rewrite 8 as 2 raised to a certain power? We definitely can. 8 is the same as 2 to the third power. All right, so we have a log base 2, and inside of that we have an exponential with the base 2, so that simplifies to just 3. All right, so this is our final answer. Okay, now let's look at part B. It says we have the natural log, which is also a log base e, of 5 times x times y. That's multiplication 3 times, so we should be able to break this up into 3 separate logs using multiplication. Natural log of 5 plus the natural log of x plus the natural log of y. All right, and so that is the final answer. So what we've done is we have expanded. All right, so we started off with one log and we've created a longer expression with multiple logs. All right, we also have a quotient property. So here, same conditions, but division goes with subtraction. So if we're dividing inside of our log, we need to subtract and break it up into two pieces. All right, so for example, log base 3 of c divided by d. All right, we see division here, so that means we need to break it up using subtraction. So log base 3 of c minus log base 3 of d. Okay. All right, then we have log of x divided by 100. Remember, the base of a log by itself is just 10, so this is log base 10 of x divided by 100. We are dividing, so that means to break it up into multiple pieces. Oops, that's just log by itself. Log of x minus log of 100. All right, so note that this is log base 10, and I have a 100 here. I could definitely rewrite 100 as 10 raised to a power. This is times log base 10, 10 squared, so that gives us our 2. All right, so that's the first two properties. They're very similar. All right, let's move on to the next. All right, so next we have a power property. All right, so again, our base is positive. We want the things inside of our log to be positive as well. Base is not equal to 1. All right, and p is just some real number. So log base b of x to the p. All right, so p is our power. This can be rewritten as p times log base b of x. So what does that mean? Well, it means that we can take our power inside of the log and move it out front and make it a coefficient. So this is actually going to be really helpful. All right, so let's look at the first problem. Apply the power property of log. So we have the natural log of the fifth root of x squared. All right, so we want to use the power property. However, we have this root, but we know we can rewrite roots as powers, so as exponents. So let's rewrite this fifth root as raised to the 1/5. All right, so this is the same as the natural log of x to the 2/5. Right, so we have something that has an exponent inside of our log. Our power property says that we can bring that exponent to the front. All right, so we have 2/5 times the natural log of x. All right, so we can do the same thing with the next one. Log, so that's base 10, log of x squared. All right, so that is the same thing as moving the 2 to the front.